Hi everyone, Assalamualaikum. In this video, we are going to continue with evaluating limits using squeezing theorem. Right? This example involves trigonometric function. Right? Find limit x approaches 0 sine 5x over 2x. Right? From here, let's say we use direct substitution to solve this limit. From the given question here, when we use direct substitution, we need to replace 0 into variable x here. Okay, then we get this. Okay, we have sine 5 times 0 over 2 times 0. Right? Then we have sine 0 over 0. And using calculator, sine 0 equals to 0. And then over 0. Right? And 0 over 0 is error because this is indeterminate form. Alright? So, in this case, we need to use squeezing theorem. Okay? We cannot use direct substitution. Right? The correct method to solve this problem is, first we look at the angle of sine. We are given the angle of sine equals to 5x. So, we need to refer the squeezing theorem limit x approaches 0 sine 5x over 5x, which is equals to 1. When we use this theorem, the denominator should be exactly equals to the angle of sine, so that we can say that this limit equals to 1. Right? But the given question, from here, we can see that the denominator is not equals to the angle of sine. So what should we do? From the given question here, the best way is we need to move out constant 2 from denominator. Then we get this. Okay, half limit x approaches 0 sine 5x over single x. Right now, our goal is to make denominator exactly equals to the angle of sine. So what should we do? We need to multiplying denominator by 5 so that we get 5x and it's exactly equals to the angle of sine. But when we multiply denominator by 5, we also need to multiply numerator by the same value, so that when we simplify, we get 1. And remember, any value multiplied by 1 will not change its original value. Alright? That's why we need to multiply both numerator and denominator by the same value. Alright? And then from here, now our goal is to make this expression is exactly like this, so that we can say it equals to 1. So from here, we can move out constant 5. Okay? We move out from limit expression, so we get this. 5 over 2 limit x approaches 0 sine 5x over 5x. And from here, when we compare to this expression, it is similar. Okay, so we can say that limit x approaches 0 sine 5x over 5x equals to 1. Okay, so we can write 5 over 2 times 1 under squeezing theorem. Then we simplify, so we get 5 over 2. Okay, this is the final answer. Alright? From the given question, the denominator is not equals to the angle of sine. So what should we do? We need to adjust the denominator until the denominator exactly equals to the angle of sine, so that we can use this squeezing theorem. Right? Here, I also want to share this technique. Right, from the given question, limit x approaches 0 sine 5x over 2x. We move constant phi outside limit expression, and we move constant 2 from denominator outside limit expression. Okay, then we have 5 over 2 limit x approaches 0 sine x over x. Okay, now from here, the denominator is exactly equals to the angle of sine. So, from here, we can use squeezing theorem. So, we can write 5 over 2 and then times 1. And the final answer equals to 5 over 2. We get the same answer. But this technique is actually wrong method. Okay, this is the correct method, but this is the wrong method. Okay, why? Because we cannot adjust the angle of sine. Right? Remember? Please be careful. Okay? This is correct. Limit x approaches 0, sine x over x equals to 1. This is correct. But the first step is totally wrong. Okay? Because in this technique, they move out constant phi from the angle of sine. So, this is a big mistake. Okay? Please be careful. Alright? Right now, we look at example 4. Find limit x approaches 0, sine 3x over sine 4x. And let's say we use direct substitution to solve this limit. Right? From the given question here, when we use direct substitution, we just plug in 0 into whatever x here. Okay? So we get this. And remember, when we use direct substitution, no more limit expression. Okay? And from here, we have sine 3 times 0 over sine 4 times 0. Then we get sine 0 over sine 0. This is not equals to 1, even we have same numerator and denominator. Okay, because sine 0 is equals to 0. So we get 0 over 0. This is error because 0 over 0 is indeterminate. Okay, so we cannot use direct substitution when we get 0 over 0. Okay, in this case, we need to use squeezing theorem because we are given in quadratic function, and when we use direct substitution, the answer gives 0 over 0. That's why we need to use squeezing theorem. Right? Here are the correct method to solve this question. From limit x approaches 0 sine 3x over 4x. Now look at the numerator. Okay, we have the angle of sine equals to 3x. So means that we need to refer squeezing theorem limit x approaches 0 sine 3x over 3x equals to 1. When we use squeezing theorem, the denominator should be exactly equals to the angle of sine. Okay? Alright. And then from denominator here, we have sine 4x. Okay? Alright. So from here, we can use squeezing theorem limit x approaches 0 sine 4x over 4x, which is equals to 1. Okay? The denominator should be exactly equals to the argument of sine. Right? Right now, we look at this theorem. Okay? From this theorem, from denominator here, there is no sine. Okay? There is no trigo function. But from the given question, we have trigo function in denominator. So, what should we do? Okay? So, in this case, if we have fraction with numerator and denominator both in trigonometric function, so first we need to multiplying by 1 over x over 1 over x. Okay? Why we need to multiply by 1 over x over 1 over x? This is actually equals to 1, okay? Because we have same numerator and denominator. And remember, when we multiply by 1, it will not change the original value. Right? But why we multiply by 1 over x? for both numerator and denominator. Okay, because when we multiply by by 1 over x, so we will get this. Okay, sine 3x over x. And from denominator here, no more sine. Okay, so it's similar to this theorem. Okay, there is no sign here. Alright, and same goes to denominator here. We have sine 4x over single x with no trigo function here. So it's similar to this theorem. Alright, and then from here we have division of limits. So from the properties of limit, if we have limit x approaches a, fx over gx, we can separate the division. So we can write limit x approaches a, fx over limit x approaches a, gx. So we can write like this, limit x approaches 0, sine 3x over x, and then over, using this theorem, limit x approaches 0, sine 4x over single x. Alright, now we have denominator with no trigo function. Okay, and same goes to this fraction. Right? Alright, now look at this. Okay, we have single x here. Okay, but the argument of sine equals to 3x. Okay, and we have single x here, but the argument of sine equals to 4x. So from here, we need to adjust the denominator so that we get 3x here and 4x here. Then we can use this squeezing theorem. Alright? So from here, what should we do? We need to multiplying this denominator by 3. And remember, when we multiply the denominator by 3, we also need to multiply the numerator with the same value. Okay, so that it equals to 1. And any value multiplied by 1 will not change its original value. Alright? And then from here, we want denominator equals to 4x. So that it will exactly equals to the angle of sine. But when we multiply the denominator by 4, we also need to multiply numerator by the same value so that it equals to 1. Okay? So that we get back the original function here. Alright? So from here, we want 3x here and we want 4x here. So we move out constant 3 from limit expression and we move out constant 4 from limit expression using the properties of limit. Okay, but we need over 3x here and over 4x here. Okay, we just move out 3 and 4 in denominator. Okay, alright, so from here, after we move out constant 3 in the fraction in numerator here, so we get 3 limit x approaches 0 sine 3x over 3x. And then when we move out constant 4 from the fraction in denominator here, so we have 4 limit x approaches 0 sine 4x over 4x. Now we have denominator exactly equals to the angle of sine. So we can use this theorem. Right? So we can say that limit x approaches 0 sine 3x over 3x equals to 1 and limit x approaches 0 sine 4x over 4x equals to 1. Right? Then we can write this 3 times 1, okay, from this over 4 times 1 from this. Right? And we simplify, then we get 3 over 4. Okay, this is the final answer. Okay. Right, the correct method is we need to adjust until we can use the squeezing theorem. Okay. You cannot simplify sine in numerator and sine in denominator and then you cancelling x here and cancelling x here. We cannot do like that. Okay. But we need to adjust the denominator until we get the denominator free from trigo function. That's why we need to multiply in by 1 over x in numerator and 1 over x in denominator. And we need to adjust the denominator until the denominator exactly equals to the angle of sine. Okay, so that we can use this squeezing theorem. Alright, got it? Coming up next, evaluating limits using squeezing theorem, example 5 and 6. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.